Let's look at question 4. Question 4 is about respiration, and it starts off with a table, and it asks you to complete the table with a tick if the statement in the first column is true for each stage of respiration in an animal. Make sure if you get an instruction like that asks you to complete a table with a tick that you do use a tick. You'd be surprised how many people use other things, and the examiners could decide to drop you marks because of that. So, let's start off with occurs in mitochondria. Well, glycolysis doesn't occur in mitochondria, it occurs in the cytoplasm, but the link reaction and the Krebs cycle both do occur in mitochondria, so we're going to tick those. It says that carbon dioxide is produced. Well, carbon dioxide is produced in the link reaction and the Krebs cycle. It's not produced in glycolysis, so we're going to leave that part blank. Finally, it says NAD is reduced, and that's true for all three. NAD is reduced in glycolysis, the link reaction, and the Krebs cycle. You get a mark for each row which is correct. So a mark if you've got the occurs in mitochondria bit right, a mark for the carbon dioxide produced section, and a mark for NAD is reduced. And I'd hope that everyone doing this question would have got those 3 marks. The examiners are trying to give you an easy one to get you started for this question. You're then given a bit of information to read through, so it's important with any question of this type that you do read through it carefully. It says that the following reaction occurs in the Krebs cycle, so straight away this is telling you that this is to do with the Krebs cycle part of respiration. It says that a scientist investigated the effect of the enzyme inhibitor malonate on this reaction. So it's telling you something significant there. It's telling you that this compound malonate is an enzyme inhibitor. It says that the structure of malonate is very similar to the structure of succinate. Now, if you remember your AS science, you'll probably remember that where you've got an enzyme inhibitor, and it's very similar to the normal substrate of an enzyme, that's likely to be a competitive inhibitor. So what it's basically telling you here is that malonate is a competitive inhibitor of this reaction. It says that the scientist added malonate and the respiratory substrate, pyruvate, to a suspension of isolated mitochondria and bubbled oxygen through the suspension. The first question we've got then says, explain why the scientists did not use glucose as the respiratory substrate for these mitochondria. This is an explain question, so we'll want to try and get the word because in our answer. Looking at this question, it's asking us why the scientists didn't use glucose for these mitochondria. So glucose isn't an appropriate thing to give to isolated mitochondria because isolated mitochondria don't use glucose. Glucose is used in glycolysis, and mitochondria don't carry out glycolysis, they carry out the link reaction and the Krebs cycle. The link reaction requires the pyruvate, which is normally generated by glycolysis, whereas the Krebs cycle requires acetyl-CoA. So mitochondria need one of those two things really to work, preferably pyruvate, which is what's been given in this experiment. So the reason we can't use glucose is because mitochondria have no way of dealing with that and metabolizing it. This is a 2-mark question, and these are the 2 answers that I've put in. I've said that glucose cannot be used because glycolysis is needed to convert glucose to pyruvate before it can be used in mitochondria. Glycolysis occurs in the cytoplasm, and there's no cytoplasm in this experiment, it's just isolated mitochondria. That gets me 1 mark. For the 2nd mark I've got to say something more, and what the examiners were looking for is that glucose cannot cross the mitochondrial membrane. Now, I'm not entirely sure that's an obvious thing to put in. If glucose did cross the mitochondrial membrane, the mitochondria still wouldn't be able to use it, but it's what the examiners were looking for in this answer. So again, this is one of those situations where you need to remember that that's what the examiners are after for this question, and if a similar question comes up again, you need to explain that glucose cannot get across the mitochondrial membrane. Next we have a question that asks you to explain how malonate inhibits the formation of fumarate from succinate. Now, we've already worked out that malonate is a competitive inhibitor, so this question is nice and easy. But this shows you the importance of reading the question thoroughly, because if you'd not read the question thoroughly, you might have missed out on the clues the examiners were giving you. To get the marks on this, we had to say that malonate is a competitive inhibitor, and you're always after some correct keywords for a question of this type, and if you remember back to AS, whenever you talk about competitive inhibitors, you need to talk about the active site being blocked, and enzyme substrate complexes not being formed. So your 2nd mark was saying something like malonate prevents enzyme substrate complexes from being formed. Finally, we've got a question where the scientists measured the uptake of oxygen by mitochondria, and they observed that the uptake of oxygen decreased when malonate was added. Now that makes sense because malonate inhibits the Krebs cycle, and by inhibiting the Krebs cycle, it's inhibiting the other processes that take place in mitochondria, and it's inhibiting those processes leading to the uptake of oxygen. So, to start off this answer, I would be explaining that malonate inhibits the Krebs cycle. But oxygen isn't actually involved in the Krebs cycle, so I need to go a bit further and explain how inhibiting the Krebs cycle leads to oxygen uptake being decreased. Now hopefully you know that oxygen is used up during the final step of the electron transport chain, where electrons and protons are transferred onto the oxygen, forming water. Now that process, the addition of protons and electrons to water, requires the protons and electrons from reduced FAD and reduced NAD. Sometimes we refer to it as the hydrogen from reduced FAD and reduced NAD because that's what we form from protons and electrons. The reduced FAD and NAD originally come from the Krebs cycle. When the Krebs cycle turns, it generates 3 molecules of reduced NAD and 1 molecule of reduced FAD. So if I stop the Krebs cycle, I'll stop the production of reduced FAD and NAD, I'll shut down the mitochondrial electron transport chain, and as a result I won't have any hydrogen, any protons and electrons, to transfer on to my oxygen to form water, and I'll stop using up oxygen and taking it up. So to finish off my answer, I'm going to explain that when the Krebs cycle is inhibited, it prevents reduced FAD and NAD from being formed. As a result, hydrogens cannot be transferred to the electron transport chain, and as a result, oxygen can't be used up, because to use up oxygen, I need that hydrogen.